Hello, and thank you for tuning in today. This is going to be a little bit different from the normal progress updates on the Heroes of Newerth 3.2.7 reverse engineering project. Instead of just showing whatever the newest thing is that I got working, I wanted to kind of go through what this project actually is, how it works, and where it's at right now. So basically, Heroes of Newerth 3.2.7 itself still works. The game executable works, the engine works, the maps work, the dedicated server works. The problem is that almost all of the infrastructure that the game originally expected to exist around it is gone. So when you launch this old client, it isn't just expecting to connect to one server somewhere. It's expecting authentication, it's expecting chat, it's expecting a master server. It needs to be able to find game servers. The dedicated servers need to register themselves. There's lobby information, player information, match IDs, and then eventually all of that has to actually lead into the game. So what I've been doing with ThorGor is basically reconstructing enough of that old environment to get the original client working again. And to be clear, I'm not rewriting Heroes of Newerth. I'm not making my own version of the K2 engine or recreating the gameplay or anything like that. I'm trying to use as much of the original software as possible. So the original client is still the client. The original Heroes of Newerth dedicated server is still actually hosting the match. What I've been replacing is everything around those pieces that doesn't exist anymore. Uh, Probably the easiest way to explain it is imagine you had some really old business software that still runs perfectly fine, but every server it used to connect to has been shut down. You could rewrite the entire application, or you could figure out what it's trying to ask those servers for and then make something new that responds in a way that the old software understands. And that's basically what this is. The hard part is there isn't really documentation for doing this. There's no API documentation that says, here's exactly what Heroes of Newerth 3.2.7 sends when it logs in. Here's exactly how the chat server works. Here's what the dedicated server expects from the manager. So most of the project has just been figuring that out. I've used Wireshark quite a bit to look at network traffic. I've used Ghidra to go through the binaries. I'd use Cheat Engine for breakpoints and watching what happens when certain things run. And then there's been a lot of just testing one thing, seeing what breaks, changing something, and trying it again. A lot of the time, you don't really know what you're looking at first. You'll just see that the client sent some bytes to a certain address, and then it's basically, okay, what was that? What did the client expect to get back? What function is handling this? And then you kind of build the protocol up piece by piece. The first major part I got working was authentication. The client doesn't just send the username and password and wait for the server to say yes. There's an authentication exchange that has to happen correctly enough that the original client trusts the response. Once I had enough of that figured out, I could create my own local accounts and actually log a normal 3.2.7 client into the backend I made. And that was really the first point where this started becoming something. Because the game was no longer trying to connect to an old dead service. It was accepting my server as if that was part of the environment it was supposed to be talking to. But, of course, logging in doesn't actually get you very far. Heroes of Newerth has a bunch of different services. Authentication is one thing. Chat is another thing. The server browser is another thing. Then you've got the dedicated server itself, the server manager, the lobby match state. And what's kind of annoying about that is a lot of these failures look exactly the same from inside the game. You click something and nothing happens. So a lot of the work has really just been figuring out which part is actually responsible when something breaks. At this point, the ThorGor stack has a few different pieces running. There's the master and authentication server that I made. There's the chat server. There's a UDP shim that's handling part of the server browser and routing behavior. There's a bridge between the Heroes of Newerth manager and the dedicated slave. There's another piece handling the native match IDs. And then, again, the actual game server is still the original Hoenn dedicated server. So I'm mostly trying to glue all these original pieces back together. Getting it to work on one computer was one thing. Getting it to work on two computers over the actual LAN was a much bigger problem, because when everything is running on localhost, you can get away with a lot. If you have a bad address somewhere, it might still happen to point to the same computer, you don't really have to worry about routing very much. Firewall rules don't matter as much, and the client and the server are basically sitting right beside each other. Then you move a client onto another physical PC and all of that changes. And that's where a lot of the bugs started showing up. Eventually, though, I got the second machine going through the whole stack, so both computers can authenticate. Both computers can connect to chat. The remote computer can see the game in the server list. It can join the lobby. The player slots synchronize between the two clients. The countdown works. Both clients can get into hero selection, and in the best working setup right now, the host can start the game and the remote machine will actually load into Codivar with it. So that was a pretty major point in the project, because at that point this wasn't just, a fake login server where I could make the menu light up. There were two real physical computers running the original game client, talking through this backend and then connecting into the original dedicated server. One of the more annoying parts of getting that working was UDP. Because TCP gives you an actual connection, UDP is basically just packets going back and forth. And when you start adding multiple clients, you need to keep track of which packet belongs to which computer and where the response is supposed to go. So that's where this UDP shim came from. It basically sits in the middle and helps route the traffic between the clients, the server browser, and the dedicated server. It isn't trying to understand the whole game. It's mostly just making sure the network traffic gets where it needs to go. And if that part gets something wrong, then everything above it can look broken even if the game server itself is completely fine. The manager and the dedicated slave were another part of this. The dedicated server doesn't just start and magically know what game it's supposed to run. The original architecture has this management layer around it. So the server needs to come online, report that it's ready, get told when there's a game, and know what match it belongs to. Getting that manager to slave behavior working was another big step. And then there was the match ID, which seems like a really small detail, but if one part of the stack thinks it's hosting one match and something else thinks it's another match, the whole thing can break even, though every individual program looks like it's running normally. So there's a separate bridge now that helps keep that synchronized. Eventually I also hit a point where I couldn't fix everything just from the server side. There were a couple places in the original client game DLLs where the behavior just wasn't compatible with what I was doing. So there are some really small patches now for K2 and game. The repository does not include modified heroes and newer binaries. Instead, the patcher checks the original file, verifies that it's exactly the version I'm expecting, and then applies the changes locally. If the hash doesn't match, it doesn't patch it. So I can be pretty certain that I'm testing the same exact historical version every time. And that brings us to where the project is right now. One of the remaining problems is hero selection on the remote client. The host will see all the hero portraits and everything normally. The remote client can get to the same hero selection screen, but for some reason it can show placeholder images instead of the actual hero artwork. And the weird thing about that is I already compared the main game files between the two computers. They're the same. So it probably isn't something simple like, oh, the remote machine is missing the texture files. It's more likely something about how that client is initializing the hero data. It could be some kind of registry state. It could be hero availability information. It could be tied to the account. It could just be some function that the host goes through correctly and the remote client doesn't. That's basically the part I'm trying to narrow down now. And that's kind of how the entire project has gone. Instead of asking one giant question like, why doesn't multiplayer work, you have to keep reducing it. Okay, do both clients authenticate? Yes. Do they both connect to chat? Yes. Can they both see the game? Yes. Can they both enter the lobby? Yes. Do both player slots show up? Yes. Okay, so now we don't need to keep debugging those things. Now, the problem is further down, and the further this gets, the more specific the bugs become. Earlier on, if the second client joined and everything froze, it was easy to think the dedicated server had just crashed. But later on, I could see that wasn't always what was happening. The server process could still be alive. The client traffic was still getting there. The routing state was still there. So now the question isn't really, did the packet arrive? It's more like, did every part of the game agree on what that packet meant and what state the player is supposed to be in now? And I think that's probably the biggest thing I've learned from doing this. An online game is really just a bunch of different programs all trying to agree on the same state. The client has state D, the game server has its state, the backend has state, the manager has state, the chat server has state, and all of those have to move through the game in more or less the correct order. You can actually have completely valid network traffic and still have the game fail because one side thinks the player is in the lobby and the other side thinks they're already loading into the match. So eventually this becomes more than just copying packets. You have to understand what those packets mean to the original software, and that's probably what I find most interesting about the project. Heroes of Newerth 3.2.7 isn't really dead in the sense that the software doesn't work. The software actually works pretty well. What disappeared was the environment around it. So I basically been rebuilding that environment one piece at a time. First I couldn't log in. Then login worked. Then chat didn't work. Then chat worked. Then there were no game servers. Then the game servers started showing up. Then the second player couldn't join. Then the second player started joining. Then both clients couldn't reach hero selection. Then they could. And now I'm dealing with things like hero assets not resolving properly and some unstable transitions when the actual game starts. So the problems keep changing, but that's actually a good thing. Because every time a problem becomes something deeper and more specific, it means all the stuff before it is starting to work normally. At the moment, two separate computers can log into the reconstructed backend, use chat, discover the same server, join the same lobby, synchronize the player slots, reach hero selection, and in the best working direction, actually load Codivar together. It's definitely not finished yet. There are still some pretty strange bugs, but compared to where this started, where I was basically just trying to figure out how to make an old client successfully log in, it's come a pretty long way. So that's pretty much where the project stands right now. I'm going to keep working through the remaining client-side bugs and hopefully get this to the point where two people can just start it up, join the same game, and play normally without having to think about any of the stuff going on underneath it. So I hope you enjoyed the video. Thank you for watching, and I hope you have a good one.